Welcome to another episode of Byte-sized RSE, the mini-series we started last year in October 2022. And this year we start with a discussion about continuous integration and to some extent continuous deployment, as they are often discussed together. As per usual, this is the accompanying episode to the interactive Byte-sized RSE session from the 17th of January 2023, run by Jeremy Cohen from the Imperial College London and Steve Crouch from the University of Southampton. After a brief introduction to the topic, I'll be talking to Sarah Gibson about her views on continuous integration and deployment and how it is used in the company that she works for. You probably know that continuous integration and deployment is a big thing these days, and in fact it helped spawn a whole sector in IT called development operations, or short DevOps. There seem to be different views on where and when continuous integration started and by whom. So for instance, I've seen a blog post crediting Grady Booch, who is also known for the Unified Modeling Language, or UML for short. Apparently continuous integration was mentioned in his book Object-Oriented Analysis and Design with Applications. But it's mostly Kent Back and Ron Jeffries who created the extreme programming methodology who are associated with CI, as well as Martin Fowler from ThoughtWorks. And you'll find a great blog post from Martin on the subject in the episode notes. So what's all this fuss about continuous integration and continuous deployment then? It is the realization that software development, whether done individually or in a team, is ultimately incremental. And as your code grows and becomes more complex with time, the risk of breaking it grows and testing and fixing bugs will take longer. Well, this may seem an obvious statement today, but in the past, teams would spend a long time, weeks sometimes, trying to ensure that code changes and additions didn't break the overall software. And this often led to significant delays in getting the software out of the door and delivered to the end users. And I speak of personal experience here. In the years between 2007 and 2010, I worked for a company called Symbian, which at the time was a very popular operating system for mobile devices. Being an OS meant it consisted of a number of software components developed by different teams, and at the time, a central team was tasked with integrating and testing code changes. That was a process that took a very long time indeed, and it prevented the organization to turn around updates to the software quickly, much to the disappointment of its customers. So how does continuous integration and deployment fit in with all of this? Well, firstly, by changing the practice in which software is being integrated. Rather than introducing large changes to the code less often, it asks developers to submit smaller code changes more frequently. In short, no more big bang integration jobs. And in fact, in many teams nowadays, there's a rule of at least one integration per day. Secondly, with each integration, ensure that the tests and other checks are run to demonstrate the integrity and correct functioning of the code changes. Code changes with failures or identified problems are going to be rejected. The rationale behind this is simple. Small code changes have generally a smaller risk of bugs than large amounts of code changes. And if you test and check each small code change, the risk of introducing bugs into the main code is reduced significantly, of course. The benefit of this is not only in terms of code quality, however, but also in terms of speeding up integration tasks and finally, software releases. Think for instance about web applications where changes to the code line can be made instantly and automatically available to your end users. In all of this, automation plays a crucial role because daily integration, even of small changes, become quickly impractical if you have to perform tests and other necessary tasks manually. Luckily, today's source code repositories like GitHub, GitLab, or other workflow tools like Jenkins and Travis come with tools to take the hard work away from you and automate most, if not all of your continuous integration and deployment tasks. Take a look at the episode notes where I list a few of these tools. Where does it all start? Well, the first job of starting with continuous integration is to identify the kind of tasks you should automate, bearing in mind that the more you can automate, the better in the long run. In short, automate as much as you can, really. A typical example of a task list is checking out your code from the repository, installing necessary dependencies and packages, running unit and integration tests, checking code styles, and or building and generating documentation. The sum of these tasks form a continuous integration pipeline or a continuous deployment pipeline if the task also includes releasing and delivering the software automatically as well. Pipelines are typically defined in a configuration file using structured text formats such as YAML or JSON. As you will hear from Sarah Gibson in a minute, these configuration files can become quite complex depending on the automation task at hand. If you have participated in the ByteSized RSE interactive sessions on the subject, you will have had an opportunity to build such a pipeline using GitHub Actions. And GitHub is indeed a great place to start, and GitHub Actions offer a great toolset. If you have a chance, I would strongly encourage you to try it out by starting with a small set of integration steps. Or as Sarah Gibson would say, start learning by doing. An objection I often hear is that it takes time and effort to build a continuous integration pipeline and automate deployment. And of course this is true. Continuous integration is not a zero-sum game, but I do believe that the benefits far outweigh the effort, even if you're working in a small team or even if you work individually. Which of course brings me now to my conversation with Sarah Gibson. Sarah works for an organization called 2I2C, which stands for International Interactive Computing Collaboration. Continuous integration, in particular continuous deployment, as you will hear, is bread and butter stuff to Sarah. And building and maintaining it is a passion for her. But hear for yourself. Hear now my conversation with Sarah Gibson. Hello, Sarah. Some of the listeners might probably remember you from last year, but maybe you can give a quick introduction.
Yeah, hello. Thank you for having me again and Happy New Year. So my name's Sarah Gibson. I'm currently an open source infrastructure engineer at 2I2C, which is the International Interactive Computing Collaboration, where my job is to build and deploy JupyterHubs into the cloud for people doing research and education around the world so that they can get on doing cool science and not have to worry about things like platform management. And I'm very involved in the open source communities, including Jupyter and also the Turing Way in terms of like reproducible research. And I'm just constantly trying to enable researchers to do what they need to do without a lot of stress around tooling and such.
Well, this episode is about continuous integration and maybe a little bit about continuous deployment as well if we have time. So before we go into how you deploy it at your end, maybe we can get a view from you what you think or what your definition of continuous integration would be and what the key components of it are.
Yeah, continuous integration and deployment are like my favorite topics. I'm
Are they
super
really?
happy. Yeah. Like it's my bread and butter. So I'm like really happy to be doing this chat today. So from my perspective, if you're familiar with Git workflow, we're making lots of very atomic commits. So lots of tiny changes to code, and we're always backing that up as we go. The idea of continuous integration is that as you're making these small changes, you are integrating them into your main code base. But as you're integrating them, you do some kind of check for correctness because you don't want to integrate something and it bring the whole project down, for example. The main components of continuous integration for me, like specifically continuous integration, is probably a testing suite. So like you've got your suite of Python tests that are like, there'll be unit tests, end-to-end tests, integration tests, whatever. And the point of continuous integration is every time you make a change, those tests run automatically. And you get instant feedback on whether your change has broken something or everything is fine. Go ahead. In practice, especially in the research community, I don't think everybody's like immediately integrating every single one of their commits. We normally work on a branch, we open up a pull request and like we wait until that pull request is like complete to some definition of like whether it's a feature and documentation and stuff. A lot of the platforms will be doing that kind of work on, whether it's GitHub, GitLab, will usually provide feedback from your continuous integration system on the pull request as to like how your tests have done and like what will actually happen when you push what's in your pull request into your main branch. And I just think that's really cool. So it gives you a lot of confidence, like what you're changing is actually going to work. But it also lets you, so this is a bit more on the testing side than in continuous integration, but also if your tests break, maybe they were supposed to break and it's like fine to rewrite them. Like if you've improved something because it didn't work well before, maybe that just breaks your tests. It's fine to break tests in that scenario, I think, as long as you then fix them for the new behavior.
Yeah, I think there are a couple of things that I would like to home in on. And I think we talked about pull requests, and again, that was done in the previous bite-sized sessions as well. But I mean, there are pull requests and pull requests. There are pull requests of what you say atomic, right, or those small changes done frequently. And then there are sort of the kind of monster pull requests, which I sort of encountered in the past, where you get somebody sitting on a pull request for a really long time. Then it very often, I find, and I don't know if your experience is that as well, that it becomes actually less testable, or the test may actually be less meaningful in that. What would you say to that?
Yeah, it will depend on like how long the pull request has been open and how and like when the last time it was like updated against your main branch. Because like if it's been open for a long time and someone's like refactored the test suite underneath and that change hasn't been pulled in, then we've got no idea of like the mergeability of that pull request. If you're writing robust test suites, large pull requests shouldn't be an issue. Like if you're writing robust, as close to full coverage as is sensible, like test suites that are run automatically, testing a large pull request I don't think is an issue. I think the issue is reviewing it because it's just too big for a single person to like actually wrap their heads around. There's always like a give and take with test suites and like how confident you are in them, but like you also wrote them and you are not perfect.
Indeed, exactly. I mean, the tests themselves can, of course, have mistakes.
Yeah,
and
yeah.
I went into that trap as well.
The biggest instant of imposter syndrome I've ever had as a coder was like starting to write my own tests. And I'm like, well, it passes, but I wrote it and I don't know what I'm doing.
Yeah, well, funny you should say that because I had exactly the same thing in the past. Yeah, that doesn't happen. So I imagine that at 2i2c, you have lots of contributors. How many people are actually contributing at your end in the open source?
It's probably not as many as you imagine on like actual 2i2c repositories. So our main repository is where we deploy our infrastructure from, and that is mostly 2i2c hired engineers with a few partners. And this is because the majority of the work we do on like improving infrastructure, such as improving JupyterHub, improving repo to Docker, we do upstream in those repositories. Our repositories are pretty much config to deploy the hubs that we are being paid to deploy and maintain. And then we have a few repositories that are like building images. So we actually don't have a ton of external contributors at 2i2c, but that's because we are pushing all of our work upstream just as they are.
I guess that you do have, you already mentioned that you do have continuous integration that you run tests with. How many bugs are you finding through that? Are you finding any?
Yeah, it's the 2i2c repository is like a weird one to talk about continuous integration about because it's not a software package. We're not finding bugs per se. What the 2i2c main infrastructure repository is a continuous deployment repository.
All right, okay. Now we're coming to the deployment bit, aren't we? Okay.
Exactly. I mean, don't get me wrong, we do have some basic continuous integration tests. They're mostly like when we rebuild our docs, check all of our links work. And we have some Python scripts in there that have like some unit tests just to make sure that that's all running. But the bulk of our repository is a continuous deployment test. Continuous deployment is then whenever you integrate a change, you deploy something new. A great example of continuous deployment is, for example, my personal website. that I host in a GitHub repository. And every time I build to it, every time I push a change to it, the HTML gets rebuilt and that new HTML gets pushed up. It's hosted on GitHub pages. As I make that change is deployed to the website. And that's like what continuous deployment is. To I2C's infrastructure repo, every time we merge something, we are making a deployment of either a new or an existing JupyterHub somewhere in the cloud that some researchers are doing work on. And we're kind of like updating that config to match the state of what we have written in files.
What we're saying is we're increasing the confidence about the code by introducing tests at an early and under continuous stage, basically each time somebody checks something in. And we're also evaluating the product before it goes live effectively, and that's the continuous deployment bit. Or is it?
No, so continuous deployment happens when you hit merge.
All right, okay. It's instantly live then, basically. Well, not instantly, but sort of quickly.
It goes live after you've hit merge. So ideally, your continuous integration does the verification, and then deployment is making that change live. However, that's fine for if it's a software package, but when it's like a platform, it's really hard to test it without just deploying it. So we tend to just deploy it in the knowledge that it's fine to roll that pull request back if it doesn't work.
So looking a little bit back into history, so was there actually ever any time at your organization that you didn't use continuous deployment? Or was that something that was actually available right from the start, like continuous integration?
When I joined, there was a simple continuous integration, continuous deployment pipeline set up. I actually spent a lot of time with team members refactoring that for speed and the sake of not doing unnecessary deploys. So I'm actually really proud of this work.
Okay.
To I2C deploys multiple Jupyter hubs to multiple Kubernetes clusters in multiple cloud vendors. So we deploy to Google Cloud, we deploy to Azure, we deploy to AWS. I think we're running at something like 60 individual Jupyter hubs at the minute. And we do this all from a mono repo, so a single repository contains all of that. One problem we had was we had like a file that described the cluster, but it also described all of the individual hubs that were deployed on that cluster as well. So we had like one monstrously long YAML file per cluster. And one of the principles to I2C has is the right to replicate, which is any of our customers at any time can decide to take their infrastructure and move it elsewhere with or without to I2C's help. They maintain that right. It is their infrastructure. But if your config for your hub is mixed in to this really long file with a lot of other people's hubs that frankly you don't really care about, it's really difficult to do that extraction and right to replicate. So the first thing we did was we started splitting out individual hubs into their individual files. This is where the Python package I just described earlier, like that does the hard work. Okay, this is the hub you want me to deploy. What files do I require? And like collating them together and doing a deploy.
I think what I'm hearing is that continuous integration and continuous deployment take actually time to implement, right? Yeah. So I think there is a cost involved that I think listeners need to be aware. But also the fact what I'm hearing from you is that it's not just a one-off. So as your product grows or changes, so will the continuous integration on the continuous deployment pipeline.
Yeah, although we do have a lot of tips and tricks. That means like every new hub or every new cluster we add, you don't need to change too much in the continuous integration pipeline because we exported a lot of that logic into a Python package. But like, yeah, as you scale, as you bring in new people with different experience in running CI/CD pipelines, you'll find more efficient ways to do things. And it is a lot of time investment at the beginning to get set up on a CI or CD pipeline. But the time it saves you over the long run, because it's doing hard work for you, that just keeps paying back dividends. And like the rest is just gardening. The rest is just maintaining.
Okay, right. But I think we should also not underrate the gardening bit. I mean, it's then hopefully sort of a minimum effort. Very often in research, when people write software for research, I've seen people, rather small teams, 1 or 2 people, and they may argue, well, ours is a small team. Okay, I get it that large teams that have a big code line where everybody contributes, we need continuous integration, continuous deployment. But for our team, it's only 2 people. Why would we need that? What would you say to them?
Just that people are not perfect. And if you're relying on peer code review, that does take time. And it's probably not as robust as a machine that just like goes through a set of checks and is like, this is all okay. There was a really great blog post thing floating around on the internet that was like the triangle of peer review, or like the pyramid of peer review. That was it. It discussed like the kinds of things that you should automate and the kind of things that like people should do. And these kind of like running checks, running your tests, linting, all of that things get a computer to do, because a human will find it boring, repetitive, and will make mistakes. Things like feature design and things like that, that's where the human comes in, because that's the things we're really good at and like it's not a thing that a computer can just run. Oh, but maybe ChatGPT will take over the whole pyramid. I
don't know. We shall see in due course. We shall see. So we may all be replaced by a chatbot one day. So, but I think basically, if you can automate something, automate it, because you shouldn't rely on your own instincts and volition to actually fix things.
There'll be days when you just don't want to do it as well, like, and that's totally fine. Have the robots do it. I also just find these kind of like writing these pipelines and figuring out how things work and how things flow together really fun. If I could spend my whole day doing CI/CD, I would.
Okay. For somebody who wants to read up on it, is there any particular blog post or book that you could recommend?
Honestly, I just kind of started because at the end of the day, all a CI/CD workflow is doing is running a command for you. So like the most minimum workflow file is check out your repository, install Python, if it's a Python project, install your requirements, and like execute a script. That's a minimum CI/CD you need. And then all of your fun stuff happens in your Python script. I never really read up on it so much as just I constantly have the all of the documentation for GitHub Actions open as like, what triggers can I use, what environment variables do I get, and like how can I link things together. And then I just kind of like let my imagination run wild on top of that.
No, that sounds good. Yeah, I quite like the approach of learning by doing, because I think a lot of people nowadays have repositories in either GitHub and, as you say, in also other repositories like GitLab. Just get going, basically, and get started. Yeah.
It's version control, right? So if it goes wrong, just roll it back. It's all good.
Well, thank you very much, Sarah, and all the best for your continuous integration and deployment at 2I2C. I always get this wrong, I always want to say 2C, 2I, but it's actually 2I2C.
It's very confusing. I have most trouble with what the acronym stands for. I'm like, need to make sure I've got that. But thank you very much for having me. This was a wonderful chat.
Okay, same here. Well, all the best for you and all the best for 2023. Cheers.
You as well. Bye.
Thank you for listening to this episode of Code for Thought Byte-sized. The content and the interactive Byte-sized RSE sessions are created and run by Jeremy Cohen from Imperial College London and Steve Kraut from Southampton University. The podcast episodes are produced by Peter Schmidt. Finally, we'd like to thank UNIVERSE-HPC for their continuous support. And with that, goodbye.